Live? Is it start? I can't see it. I can see it. Have I switched on? Can you hear me? Hello? Sophie, overcompensating. I like that. Hi everyone, sorry about that. That was, yeah, good. That was just the usual tech debacle. Hopefully it's all working now. Not the lecture I wanted to lose 17 minutes in. So whatever we don't cover today, we will cover tomorrow. And if we don't cover tomorrow, I'll record an extra video as well, just so that we can get through the content. Okay, so welcome back. I hope you all had a good weekend. We are in week 5. You're almost halfway through the term. You've got an assignment. 22% of you have started that assignment. The rest are still, I don't know, just twiddling your thumbs, please start the assignment. The due date will come faster than you know it. Okay, excellent. So last week we started with 2D arrays. We also did some strings, and we did not do command line arguments. I don't know why that says there. That's aspirational. We're going to be doing that today. And we are going to be doing more of 2D arrays today. I was planning on doing a bigger program with 2D arrays to help you get started for your assignment 1. Who here in the theatre has started their assignment 1? Oh, this is not the audience that I'm looking for. I'm looking for the other. Oh, you've started it too. Oh, good for you. I'm looking for the other 77% that hasn't started. Who has done stage 1? Oh, look at you go. All right. Well, maybe we can do a little bit of that big program. And you just get another recap. Okay, and then we're going to do some command line arguments. For those of you that don't know what it is, you're about to be in for an absolute treat. Okay, live lecture code. I don't want to do that yet. Sophie, can you please I should have been doing that poll before we even started. Can we please do a poll of who wants to do 1 or 2 more functions for 2D arrays before we do a bigger problem? Okay. Poll, sorry about the way the coughing sounds. Okay. Yeah, like you don't have to be finished with the assignment. It's slow and steady wins the race. Who wants functions? Not functions. 2D arrays. A few functions with 2D arrays. Sorry. I don't think anyone wants functions. They know what functions are. Everyone said yes. Well, you're getting functions and you're getting 2D array functions. This was not the question I was looking forward to. Okay, excellent. Can you redo that poll for me, please? Sorry, that one is not telling me so much. Okay, 2D array, excellent. So what did we do last week? We did some grid as a function, and that's it. So we're going to do one more function, and we're just going to talk a little bit about what's going on with 2D arrays. Okay, so I really should have brought my puffer. Okay, let's talk. What should we do now? Should we go through and find the maximum number in our array? How does that feel? Does that feel all right? Or everyone's dying a little bit? What's happening? Monday? Okay, I need energy because I'm dying a little bit. We have new lollies, guys, so get excited. You say as you show them the lolly and then put it back in the bag. Okay. All right, so let's do one more function here. To find the maximum number in the 2D array. You know, I spent so long, do you know why? It's because I connected my Apple Pencil to it instead. Oh my God, what a Monday. I went through the lectures, so the online people enjoyed that. Jeez. All right. All right. Is that better than an Apple Pencil? Yeah. Oh, well, my pencil is charged. All right. So let's do a function that will help us to find the maximum number in a 2-dimensional array. Okay, so what are the inputs? What are the inputs into the function and what is the output out of this function? So we want to find a maximum number in a two-dimensional array. What we're going to give this function to do that with? We will give it an array. Yes, how amazing. We'll give it a 2D array. And what is the output going to be if we're finding the maximum number in a two-dimensional array? An integer. Yep, excellent. It'll be that maximum number. It'll be an int. Oh, just, just go to town. It's a heavy... Okay, so int, and then we've got, I guess we'll call it max number. And now we're going to say what the inputs are into this function, and we're saying it's our array. And if you remember last week, I said, okay, when you give an array, you need to say the number of columns always. Now, does anyone know why we need to give it the number of columns? Or you did what I asked you to do, which is just believe me, and that's it. So the reason we give it the number of columns is because in memory, a two-dimensional array is actually stored kind of like this. So let's say the array has these numbers in it. In memory, it would be stored 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 in a contiguous array, one after another memory segments. So we give it the columns numbers so that it can actually know when to switch over. So we're projecting it like a grid, but that's not what it actually looks like in memory. So we always have to give the number of columns, and I give it the number of rows as well, so it knows how big the array is, but that is something that you can change. So the rows can be dynamic. You don't have to always have the same number of rows. Okay, so we need to find a maximum number. What do we need to do should we store that maximum number somewhere? What should we do? Yep. Sounds good. So we're going to have a variable that's going to be storing the very first thing in the array. He's not as aerodynamic. Okay. But good check for whether you're awake or asleep. No, I want you to get better. I want you to improve. There is... Yeah, practice on weekends. Okay, so the first thing we're going to do is we're going to have a variable. I'm going to call it maxnum, and I'm going to assign the very first thing in the array, which is array at index 0, 0. So I'm going to say, okay, that's going to be the largest number. I don't know what else is in this array, but we're going to go with that's going to be the maximum one. And now I want to go through the two-dimensional array. So to move through the two-dimensional array, I'm going to have some nested for loops. And those nested for loops will help me traverse my array. So the first one, int I is equal to 0, I is less than rows or columns. Okay, so we start with the inside, so the outside rather, and then we go on to the inside. Okay, and we're going to increase it, and then here we're going to go int j is equal to 0, j is less than columns, and we're going to have j++. Okay, now we're going to need to check whether our whatever is in our array is going to be bigger than what we have our max number set to. So how will we check for that? Will we have an if statement? Yep, so this will allow us to check if a condition is true or not. So we're asking a yes or no question, which means we have an if statement. And the if statement is going to be if, so we've got our max number is going to be if it is less than, no, yes, oh my God. Okay, if array at index I, index j is greater than the max number, for some reason that was much easier to think that way, then what happens if whatever in my array is greater than that max number that I've set? Yeah, I changed the max number. So I want my max number to be array at ij. Okay, and then in the end, we're going to return the max number. Okay, how does that feel? That feel okay? Just that single person felt that it was okay. Okay, and then I'd say we'd have to call it somewhere. We'll have to actually call it. So in my main, I'm going to call it. And I'm going to say the max number is. And I'm going to call the function, and the function is max number. And I'm going to give it my array, which is called array. That's convenient. Perfect. Okay, let's see if it's working. Okay, that's not working. So DCC 2D arrays, that's not what it's called, array.c. I'm going to get over doing that. Okay, there we go. All right, excellent. So it compiles. And let's run it. And our maximum number is 12. Am I just going to believe everything I see? Will I try it somewhere else? I'm going to make this 22 and then try it again just to make sure it's working. Well, that doesn't actually make sure it's working, but it's just testing one more time that it's going to pick out the biggest number. What else should I try? Yeah.
I have a question.
Yeah.
Why do we go through the rows first and not the columns?
So you could go through the columns first if you wanted, depending what the question is asking. But because, so often the logic is that, okay, I'm reading left to right, then I'm going to the next line left to right. But some questions actually go the opposite way. Like sum up the column, we will change the way we're doing columns and rows, and we'll do the opposite way, depending what we're actually trying to do. Yeah. Good question. Okay, I'm going to make this the big number, because the first one is the one that I set to start with, so I always want to check the first thing, whether it's working and whether it's actually getting the first thing. Yes, it is. So this is potentially working. You could test it for a whole bunch of other things, but I'm feeling the pressure because it's 11:31, and we have only done one function. Okay, was there another poll? Did we do another poll? I've lost the whole window of the questions. 73% wanted it. Do they want one more function? Oh.
They probably will say yes.
What? Sorry, what? Too many polls. Okay, let's do one more function and then we're going to move on. And do you want me, people are saying no online. Yeah, so you were wrong. Maybe you don't know them as well as you think. Yeah. 3D array, please. I'm not doing a 3D array. That is not part of this course. Okay, 4D array. Sure, we'll just keep going. We'll do a 100D array. And we'll have a whole bunch of nested for loops to access the elements. It'll be so fun. Hey? It will break the style guide. It'll be a function inside a function inside a function inside a function inside a function. We could do recursion. All right. Is memory management this week? I hope so, but my gosh, it's going well. Okay. No, did you, what? Oh, I'm sorry. That's enough for now. Okay, who wants to do the bigger program that is like kind of like assignment 1 to help you get started with stage 1, even though everyone in this audience has basically started stage 1. but maybe not online. Yeah? Yes? Okay, let's do that. All right, so I'm not going to cark it, I swear. I just sound terrible when I cough. I'm sorry. I've had pneumonia a few times, so my lungs are quite bad. Okay, so we're going to do something a little bit similar to, like a very basic, similar to the assignment. Definitely not like the assignment. Okay, seeing as half the people left to go for lunch last week, I thought you must all be hungry during this lecture, so. And I'm hungry too, but not for any food that will actually sustain me, just for something sweet. Okay, so basically you're navigating a grid-based map of the university. It's just not my day today. Navigating a grid-based map of the university with a mission to collect every churro hidden on the map. Now, the map is an 8x8 grid. So similar to your assignment 1, you've got a grid that's forming your gameplay. You will have a user that will input the starting coordinates of the player. Then you will have some walls that will stop you from going to certain places. Then you will have the churros that you are going to be collecting that you will input into the map. Okay, then you'll have this gameplay phase. So similar to your assignment, you're going to print out the map after every move. You're going to use WASD to move. You can't walk into a wall, and if you walk into a churro, you have to collect it and count it. Okay, and then you end when all the churros are collected, and you can press Control-D anytime to end the search. And there's a side quest if we have time, although I highly doubt it at 11:35. But we shall try. Okay, you're going to get some starter code, just like you do in the assignment. And the starter code will help to initialize the map, and it will also print out the map, just like in the assignment. But you get a lot more in the assignment. You're going to get an enum in this problem as well, just so, like in the assignments, just so that you can see that the enums are used. And the enum is going to have a tile, which is going to be marked empty, wall, churro, trap, or player. So depending what is on that tile, you're going to have a different meaning to it. Okay, then you're going to have a struct. The struct is only going to be made up of one thing because this is just the beginning, and it's up to you if things go on that you can add things to your struct as well. But the struct is basically going to be composed of that enum for now. So what that means is that your map is an array of structs with an enum tile inside each one of those structs. Okay, so it's like it's a real trip. It's an enum inside a struct inside an array of arrays. Yeah, that is actually quite trippy. So an 8x8 array. Each one marked as an index, and each one of them is going to have inside it, for example, this one is going to have the name of the array map, the indexing, 40 in this case, and then dot tile to actually enter this member of the array, to enter that struct. So you have an array of structs, then each struct has an enum in it, and then each enum has a whole bunch of elements in it that it might be. So if you are setting one of them to start with, then, for example, using that same one, so that map at 40, and you access the tile element of the struct, and because then you set the enum and you set it to empty or whatever else is on that spot. So you assign a value to it. So for example, looks like something like this initialized. So let's see, this is the player. So, well, this is nice. This is the wrong values. Okay, I'm going to do it without this because I've got to fix those. That should say map 00. This is what happens when you get too far into doing something and then lose the plot. Okay. Okay, so our starter code, it's, I think, available to you already. I think I chmodded it. and some also chmodded some binary, some executable files. I'm sorry if you see a weird file, it's because I chmodded everything because I'm lazy. So you are going to have some starter code. You don't, well, it helps to understand it a little bit, but you don't need to understand every single bit of it. Just like in the assignment, the first thing you should have done is gone through and looked at what your assignment has already provided you and what those functions are doing in the assignment. So in this case here, I've got some hash defines, and those were the commands that I move with. I've got the size of my board here for hash defines, and then I've got the enum that I just talked about, and then I have the struct with the enum inside it that you might or might not want to add more things into. For example, in your assignment, you might want to supplement that struct with other things depending what is useful to hold on to and what information you want to hold together. Okay, you get some starter things, and the starter things are down here. So hypothetically, you don't need to understand them, but it's useful to have a look at them to understand what they're actually doing. And then your main function, which actually shows something going on and something starting. Okay, so let's do the first thing. So the first thing that we had to do was ask the player for where they are. Yep, so starting coordinates of the player, then the walls, then the... So if we run this, just to see what it does to start with, it's not going to do anything. It's going to... I hate these microphones. Okay, so we're going to declare an array of type struct. So the array is going to hold inside it structs, and it's an array of arrays. So it's got map rows, map columns. We're going to initialize the map, which means that every single element inside that array of arrays is going to be set to empty. So if we go down to the initialize function, all it's doing is it's setting every single tile in that grid to empty to start with. Then we're going to print a welcome. If we go down, it's just going to be a nothing function with 3 little printfs that makes it look pretty. Then we're going to print the map. And if we go down to see what that does, all that does is it accesses what's going on at each tile. So if there is a player on a tile, it's going to print a P. If there's a wall, it's going to print a hash. If it's a churro, it's going to print a C. A trap, it's going to print an exclamation mark. And otherwise, it's just going to print a dot. So if it's empty or whatever else. And then we're going to print some new lines and we're going to exit. So far, this is doing nothing. Just like your assignment, when you first looked at the starter code, it would be doing a whole bunch of nothing. So if you compile it, okay, so all it's printed out is a map, and then that's it. So what we talked about, it printed out, this was the print welcome bit, so that's this function. And then this bit over here is printing out, is initialized, the map's been initialized, and then this print map is what's printed out this map. Okay, so the first thing we're going to do is we're going to ask where the player is going. Yep, does that sound good? So good. That sounds great, Sasha. Thanks, Liam. I know where I'm going to get at least some input. Okay, great. Where are we going to do that? Where should we do? Oh, so sorry, I just did a.out. Okay, yeah. So a.out is when you're super duper lazy, and I didn't do -o and named the file that came out, the executable file. I didn't name it the same thing. You don't have to. When I just compiled without naming the executable, it produces an a.out file. So if you have a look here, it produces this file, and that's the executable file that runs. So that's all I did. I was trying to save time, but created more questions. I'm sorry. Okay. Okay, so where are we going to ask the user where they're going to put the player on the map? What do you reckon? We're going to ask it over here. We're going to ask it after the print welcome. We're going to ask it before they print the map. We're going to ask it afterwards. Where should we ask it? So this declared the whole thing, so it drew up a grid for you. This marked, so this initialized that array, so it put every single thing to empty. So I think we should do it over here, right before we start doing any printing. We should now, because everything right now is set to empty. So when it did this, what it did is it set every single thing to empty, which is the dot. So now let's put the player on the board. Okay, so what should we do? We should ask where the player should go, right? Pardon? Yeah, we want some coordinates. Let's just ask where they go. Okay, so the first thing we want to do, we can save the player's location in somewhere. We don't have to, but we can, let's just start simple. We'll print it out, then we'll see what else we need as we go, just like you would probably start when you're doing your assignment. Okay, so the first thing we'll do, we'll say enter the player's starting location. Okay, great. Look at us. We've got one more thing going on as a printf statement. Now we need to take in that location, a row and a column. So what are we going to use? Scanf, yep. So we're going to use scanf to take it in, and we've got a row and a column. So we're taking in 2 ints. So what are we scanning in that means? Yeah, so we're going to do %d space %d. We're scanning in 2 %ds, and we're going to place them inside. Well, I've got nowhere to place them right now. So where should I place them? What should I do to place them into something? Yeah, so I need some sort of variable to hold my player's coordinates in it. And what could that coordinates be? What should that variable be? Should it be 1 variable? Should it be 2 variables? Should it be something else? I can have 2 integer variables. I can indeed. So if I, let's say, have int, is there any other way I can do it? I can have an array of 2 values. I can. What else can I do? I can have a struct because they're an x and a y coordinate, so they're like a related location together. Which way would you like to do it? You want to do it as a struct? Let's do it as a struct. Okay, so I'm going to comment these out because they are, so all of these are ways to solve this, right? There's always more than one way. Some ways are going to be more efficient than others. We don't as much care about efficiency in 1511, so you can just, you are free to experiment. So we're going to have a struct, and that struct is going to be, we should probably define it first. So let me define it here. So I'm going to have a struct player, and this is going to have int x, int y. Can I just do that? So I'm going to have a struct here that's going to hold the coordinates of the player. Yeah? Okay, so sorry. Okay, great. So that means I want a variable of type struct player. So I'll have a variable of type struct player, and I need a variable name. What should my variable name be? Sasha. Oh, well, that's one-dimensional. I prefer hero. Anyone? Anyone? Just anyone? Good variable name. Go on then. You're killing me. Hero it is. Okay, great. I have a struct player, and inside that hero is 2 things. There is an x and a y, and they're both int. So now when I scan into them, I can say, okay, I want to put it inside the variable hero, and I want to go into the x coordinate, and then the other one, I want to go into the y coordinate. Yep? How's that feeling? Great. So what happened now is inside this, I have my x coordinate. Inside this, I have my y coordinate. Do you think it's going to change the way the map is printed now? What do we reckon? Is it still going to print the same thing? Is it now going to put the player on the board? No? Why isn't it going to put a player on the board? Yeah, because my tile is still not set. So I've got the coordinates, but it's judging what is happening inside that map based on the enum tiles, because the map is made up of the struct locations. So my two-dimensional array is composed of these locations, and inside this location is the enum. So that means I need to now let it know that at that coordinate I have this thing called a player. Yeah? Okay, so how would we do that? So we've scanned in our thing. Our array that we've declared is called map. So now I want to set my map at location. What location will it be? Where's the player standing? Yep. So at hero X, oh, struggle town. And hero Y. So great. So now I'm inside this map. I've set it to go to this index and this index. And my map is an array of struct locations. And inside the struct location, there is an enum tile, which means that that is the only member I can access to assign things to right now. So I'm going to assign to it by saying .tile. And because I want the player to go there, what will happen is I'll take this player and I will set it now to be player. Okay, great. Let's have a look what that does. So let's compile it now and then see what it does. I'm going to keep using a.out. You know, what did I forget? A semicolon after my declaration. Okay, compile again. And now I've done something else. What have I done? Pardon? Oh, I did. I used a comparative, not an assigning. Thank you very much. Good job. Okay, excellent. And let's see what it does. Player starting location, fantastic. So if I do player starting location at 2, 3, it's now giving me the player here. So 0, 1, 2, 0, 1, 2, 3. So it's giving me the right place. So this is nice. Your player's now on the board. Excellent. Can you, Sophie or Bella, can you do a quick poll if anyone wants me to do it as a writing? To draw out what the code is doing. I'm sorry, that is a very long sentence. Next, we're going to place the walls, I think, which is so exciting and similar. And we're going to do it as a function, I think. Yeah? What? Can I chmod again? Oh, no, it hasn't. I saw that it wasn't a, sorry. There you go. That should be all right now. Okay. All right. That feels resounding. But you know what I've done today, which it hasn't worked. Yeah, but it was going to. I had a, that's why I was charging this pencil. And it's still not working. Why isn't it working? Probably not. No, why would I spend money on that? Yeah, that's why I had it plugged in, but I plugged it into the, I don't have a, it's got a USB-C to C. Well, that was all going to be good. Now I'm going to have to draw a ridiculous grid. Well, that's not helpful. Okay, let's draw it out. I'm sorry, I had an iPad, but you're in for an ugly drawing again. Yes. Okay. Oh, thank you. It's good to see that people are prepared. Not me. I am chaos personified. It was working upstairs, so obviously I did nothing to prepare for it not working. No, but it's working for my fingers. It might just be like, it's Monday, so it might just be like, give me a second. Okay, I'm going to start drawing without it, because so as not to waste time. Okay, so let's have a look. So this is what we've got going on. How did you do the rectangle? Control Z, that's it. Okay, so we have an 8 by 8 grid. That failed miserably. Yeah, I could have, but I didn't. 1, 2, 3, 4, 5, 6, 7, 8. There we go. This doesn't count. This doesn't exist. Okay, amazing. This is costing me so much health and strength. Okay, so let's have a look. So what this code is doing. So this line over here, this struct location map rows, map columns, what it's doing is it's creating this structure. And so it's creating an 8 by 8 structure starting at 0 over here and 0 over here and counting 7, 2, 3, 4, 5, 6, 7. And similarly here, the same way down the columns. Okay, great. So it's saved some space for this two-dimensional array. Okay, in memory, it's created the space for it. It's ready to go. Then it goes down to this initialize map. And what it's doing for this initialize map is if we go down to our function initialize map, what it's doing here is it's doing the nested for loops. So it's going for your rows and for your columns, it's setting every single tile to empty. So it's accessing each one and it's setting it to empty. So what this function here is doing, it's got an R, so I'll go just once through this nested loop just so you see what it does. So it goes R is equal to 0, great, I've got my R, it's equal to 0. I'm going to check that R is less than maps, it is, because map rows is 8. Then it goes down, it creates a C, and it sets it to 0. Excellent, it'll check that C is less than 8, it is. So I'll go into this for loop and I'll access map at index 0, 0. So that means I'm looking at this thing here. So when it created this, because it's an array of structs, each one has a struct location in here. So each index kind of looks like this, where it's also holding a struct. And each struct has a tile in it, an enum. So I've got this enum in here, this is the tile, and my struct is composed of that tile, right? So to access that tile, I do a dot to access the member of the struct tile, and I'm going to set it to empty. So this sets this to empty, and then it increases your C by 1. So it'll increase the C by 1 and it will go again. So now you're going to be at 0 and column 1. And then you're going to set it to empty. And so on and so forth as you go through. So this function is setting every single thing here to empty. So it will finish when it will initialize the whole array of arrays. And it will set every single tile in there to empty. Okay, great. So we've done that now. So now we're going to go down, and now we've got a new variable. And this variable is called, it's just a struct, and this struct is called player hero. So what will happen is you'll create one more struct where I'm just running out of space to draw it. I'm going to draw it here. So one more struct here, and this struct is made up of an X and a Y. So this is declaration of it, but we haven't initialized it yet. So you go to line 44 here, you enter the name, and then when you scan F here, what you're doing is you're scanning into the X and the Y coordinates. So that means at this point, I've given it some sort of values. And let's say, for example, I gave it the value 2, 3. Excellent. So now I have these values in here, but my array of arrays, my array of structs, it's still all set to empty. So what I'm doing on the next line is I'm actually putting this player, these coordinates, I'm putting the tile with the player onto my map, onto my grid. So I know that hero.x is accessed by saying at index 2, and I know that this one is accessed by doing at index 3 because it's hero y. So the map is the name of my array of structs over here. And each struct has inside it a tile, just got one thing. So I access it by doing dot tile, and I'm going to set it to, that says player, that doesn't, we've just cut off a little bit there. So that says player. So what I'm doing is at index 2, 3, I am now going to set it to a player. So now I'm going to make it a player. So at row 2, so row 2, column 3, this is now going to become a player, whilst everything else is ease around it. So that's what you do with that bit of code that we just wrote. How does that feel? Awful, I know. An enum inside a struct, inside an enum, inside a struct, inside a... Why are people talking about food again on there? Feels, anyone feels anything at all? Are you all numb inside? What's happening? What? You're feeling educated? It's good timing for that. Okay, great. Have your critical thinking skills developed, Liam? That's the most important thing. Okay, does that feel okay? I'm erasing. Too late now, forever hold your peace. Okay, 12:02. How does everyone feel to keep going for another 2 minutes and place some walls? Is that okay? Yes? Yes, okay, let's keep going. All right, thank you for the vibes. Okay, great. We've now got a player on the field. Before we print anything, we're going to place some walls. And let's make it a function, okay? So let's do a function here to place some walls. Yay. Okay, so I'm going to call the function place walls. Amazing. And I'm going to assume that that function is going to need the map on which I will place those walls. Okay, great. Now I need to actually write the function. Okay, so function to place some walls. And this function is going to have some inputs and it's going to have some outputs. Okay, what's going to be the input of the function? Well, I'm going to give it something. I'm going to give it the map. Yeah. I need to tell it where to place the walls. So I'm going to give it the map to go with it, to run. What am I going to output? Am I going to output anything? Nope, I'm going to output nothing. Okay, great. So my function is void. It's called place walls, and I'm going to give it it's not an int, it's a struct. It's an ugly, ugly struct. Location map and map rows, map columns. Okay, great. So I've got my function definition here. It's going to place some walls. It's going to be amazing. Okay, I want to know how many walls I'm going to how many walls I'm going to place. So I'm going to have a variable int num into which I'll save that number. I'm going to ask the question. Yeah.
When you pass the array, the map to the function, is that not making the map in the function a local variable in that function, or is it
What?
if you make edits in that function, do those edits apply to the map?
It is such a fantastic question, and the answer is okay. Oh, I'm trying to explain it without what you're about to learn tomorrow. But the answer is yes, it is making a copy, but it's making a copy of an address, which means that it will change it in the location we want to change it, which means that we don't. So an array is a decaying pointer, which we will talk about tomorrow, which means that when you pass an array, you pass the memory address of the first item. And because you've got the memory address, even though it's a copy of the variable, it's holding an address still, which means you're changing things at location. Yeah, no worries. Okay, excellent. So how many walls would you like to place? Everyone is probably feeling relief because this is an easy one, and I'm just going to scan it into my num. Okay, great. Now I know how many walls they want to place, and now I want the coordinates of each one of those walls. So things are about to get fun. So I'm going to need a loop because I'm going to need to loop for how many walls they want to place. And each looping of the loop, I'm going to ask for a row and a column of where they want to place that wall. Okay, so let's do it. What's going to be my conditional here? Just a quick check that you know what the heck's going on. Num, excellent. Okay, because I'm counting how many walls I'm placing. And in here now I want to print and I want to ask them where would you like to place the wall. Okay, great. What am I missing here? Exactly the same thing I was missing with the player. I've got nothing to store these coordinates in. So I'm going to need some variables to store them, okay? So again, I can do them as a potential struct, but I don't know if I want to. I'm just going to have a row and I'm going to have a column to store them, and then we can decide if we want to change that. Okay, great. So we're going to scan into those two variables. So we're going to scan into row and we're going to scan into column. Fantastic. So in here now we've got two variables, row, column, and we have stored the first wall in there. Now, does that mean that it is now on our map, or do we have to place it on the map? Yeah, we still have to place it on the map. So right now it's just two variables that, where did my loop go? It's literally 2 lines above. Okay, so I'm going to place it on the wall, on the map. So map at row, because that's where because those are the two things that I scanned in here. So I want to use these variables to tell me where to place something. I'm going to access the tile member of the struct. And then I'm going to make it a wall because the enum is, or a qual. Okay, great. So that means that I now have a wall, okay? There is no conditions yet for this wall. I'm placing it anywhere. I can apparently override it as well. I can override a player. I don't care right now. I've just placed a wall. So like, don't try, when you're programming, don't try and solve every single problem at once. Do one thing, test it out, then think about what you need to actually consider. Okay, so let's see if it's working. And we're going to do a prototype. And let's see what it does. Okay, so let's compile. Amazing, it compiles, and we're 8.out. Okay, player starting position. I'm just going to do 2, 3 again. How many walls would you like to place? I'm going to place 1 wall just because I can't. Okay, great. Is that working? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay, fantastic. We've got a wall. Things are going well. Okay, so we've got a player, we've got a wall. Now, as I said, I can actually break it if I then go, okay, player's location is 2, 3. I'd like 1 wall, and I'm going to put that wall at 2, 3 as well. Well, now the player's gone for walkabouts, and I've placed a wall there on top of the player, which is probably not that nice. Squished. You don't have to do this assignment. Don't worry about it. You have encountered a wall. So I think we need to do something about that. What do you think? Probably a good idea. And in your assignment, you also have to do something about it. You need to kind of take care of those, to not put things on top of each other. For now. Okay, great. 12:10. Does anyone need a 2-minute break? Are you cooked? Do you need a little break? One person says no, everyone else says yes. So we're going to have a 2-minute break. 12:15, okay? We come back. Even if we don't do command line arguments, we do them tomorrow. Thank you so much. Hey?
We're just getting an odd question.
That's your problem. We're back, 12:15. We're locking in. No Kahoot. I was going to, but the moderators just let me down as well. They said, no, we've got to lock in. That's such a fun Kahoot too. Anyway, no, I'm not going to go there. Okay. Fantastic. We now want to place some walls. We've placed some walls. And now we've realized, oh, our walls are going on top of other things and it's just all chaos, which is fun, but doesn't quite work how we want it to work. So we're going to check the validity now and not place things on top of each other. How does that sound? Does that sound amazing? I thought it did. Okay, and you know what? I'm going to do it as a function as well, because why not? So function to check valid input. Okay, fantastic. So if I'm going to be checking whether something is valid input on the map, so like let's say right now I put the player at 2-3, but what happens if I put the player at 8-8? What do you think my program will do? Pardon? Yeah, it will not be happy. It'll crash because I'll be outside of the boundary of that map and there's nothing preventing me from doing that. I can do whatever I want right now. And the freedom is just so amazing. So we're going to need to check whether or not it is outside the boundaries and whether there is anything on that board. Okay, so what do you think will be the input into a function that's going to check whether we're outside the boundaries of the map and whether there is anything on that map? What do you think we need? We need the x and y coordinates. I agree that we're checking. So we need the int row, we need the int column. So the two coordinates that we're going to check against our map. And what else do we need? Which I've kind of just said. Pardon? Yeah, the map, the actual grid. So the player is going to be an int row column or the wall or whatever else. So those are the two coordinates that we're checking. And then we also need the map that we're checking against. So we've got our two coordinates in row and column, and then we're going to check against the map whether there's anything there or not, because that will allow us to see if it's empty or it's not empty. And what are we going to return? Because we're checking whether it's valid, we actually want a return out of it. And what do you think we could check for the return? 1 or 0. It's either valid or it's not valid. So we're going to output an int and we're going to output 1 or 0 depending if it is a valid move or not. Okay, great. So we're returning int. That means that we're going to lead with int, and I'm going to call the function check validity, and I'm going to give it a row, I'm going to give it a column, and I'm going to give it the, what's it called? The map that I'm checking against. Okay, fantastic. This is going so well. We've got one thing going. So the first thing let's check is whether it's sitting outside of the boundaries of the map. So whether I've stepped outside of the map when I've given a coordinate. So what do you think I'm going to use to do that? Yep, an if statement. Okay, and what will I be checking inside that if statement? What do my coordinates have to be? What does my row and my column have to be? Does it have to be greater than 0? Yes, it does. So I'm going to check, which way am I going to check? Am I going to check for the false or the true? It doesn't really matter, right? However you think. Okay, whatever makes most sense to you. I like to check that I'm outside, so I'm going to go this way, right? But you can check the opposite way as well. So if row is less than 0, what else am I checking for? I'm going to leave the condition empty for now, and we will fill it in. Am I checking now that the row has to be what? Yep, greater than or equal to map rows, which will place me outside. Great. And then I want to check the same thing for columns. So the column has to be greater than 0. So I'll check, is the column less than 0? Is it negative? Or is the column greater than or equal to the map columns? Okay, now, what do I want to do in between them? Do I want to have an or do I want to have an and? Oh, I think it's a poll. Yeah.
You're checking if it's outside any of them, so
Yeah. Yeah.
outside any is invalid.
That's right. Because I'm checking if it's outside any of them, I'm going to do an or because I want it to just stop checking. It doesn't matter if it's, I don't need it to be outside all of them for it to be okay. If it's outside any of them, it's already invalid. Yeah, so it's an or. So let's check that I've got all the conditions. I've got my rows is less than 0 or rows is greater than map rows. Then I've got my columns is less than 0 or my columns is greater than or equal to map columns. That's all of them, right? Yeah. Okay, so if any of those are happening, if any of those are outside, that means I'm going to return 0. Yep. Okay, and now I want to check that there is nothing else on that board for me that will stop me from doing something. Okay, so what do I want to check now? Which I didn't make any sense that I've said. I want to check whether the map at position row, at index row column, dot tile, missed a square bracket, no one's commented. I want to check that it is equals or not equals to empty. I like going in the negatives. Okay. Yeah.
Should you not check if it's equal to all? Because if you're checking if it's not equal to empty and there's a churro there, or one of the goal things.
We're not up to the churro yet. Just
Should you not include it first?
I'm going to go negatives as well in the main. Great. Just hold that thought in like 10 minutes. Yeah.
It shouldn't be equal to map rows, right? Because map rows is like the number of things. Like the last index should be like minus 1.
Yeah. So I'm checking. I'm going to return 0 if it is equal to map rows. As in, don't do it. It's yeah. I've gone the opposite way. Okay. So if it's not equal to empty as well, so if there is something on there, for example, and we haven't accounted for anything yet, just if it's not empty, then I'm going to return 0 as well. Okay, otherwise I'm going to return, where am I? 1, 2, 3. Am I missing a bracket?
You've got an extra closing square bracket after
After empty.
Yeah, there's not
I
gonna be a-
do, thank you very much. And then have I got enough brackets here? 1. That's closing that, that's closing that, that's closing that. Okay, that should be okay. All right, we'll see in a second if I've, okay. So this is checking whether I'm outside the board or whether something is not empty. And we can, maybe, can you do the poll already, whether you want me to run through the code and write it out? Draw it out, that's the one. Yeah, just read my mind, Bella, read my mind. You are that good. I've got faith. You can only stop reading my mind after 8 p.m. Okay, great. So we've written a function that will check whether or not we're outside the board or whether or not it's empty. And now we want to actually use that function. So I'm going to use it inside my place walls function, because I don't want to place a wall if I can't place it in that location. I also don't want to place a player, but we're not up to that yet. Okay, so let's do it. So I've got, where would you like to place the wall with a spelling mistake? And then I've scanned in some numbers, and then I've set it to the wall. Okay, so I think over here, after I scanned in the numbers where they want to place the wall, is where I should also check whether or not it's valid input. Yeah? Does that feel all right? Maybe? Okay, and if it's not valid input, I'm going to ask them to enter something again. Okay, so every time that they have invalid input, I'm going to ask them to input another row and column. So I'm going to make a while loop, and I'm going to check. I'm going to call that function that I've done, and I'm going to send it row, column, and I'm going to send it the map. And now I want to do something. So what will this return? So right now, if it cannot go there, it will return 0. Otherwise, it'll return 1. Is that what it's doing? We can try it out. When you're unsure and you've gotten confused in the code that you've written, so I want to say invalid spot, try again, and then we're going to scan in again. And we're going to put it inside row and inside column. Okay, should we try it? It might not work. Probably won't. So let's see what it does. Okay, so I'm going to compile it again. And I'm going to run it. Player, I'm going to press that. How many walls? I'll do 1. Now I'm going to try and place a wall outside of my array. So I'm going to do 8, 8 for the wall, and it crashed, right? So it still tried to access it. This check did not work. And why do you think this check did not work? Shall we have a look why? Yes, we absolutely should. I cannot believe it didn't work. How outrageous. I actually can believe it didn't work because there's something missing. So row column, let's say we've given it an 8 and an 8 and the map. Yeah? Let's go and run this function, and then you can see why it did not work. Okay, I'm going to clear that. I'm going to give a little bit of space here, and we're going to go here. So the function has been called. The function's got 8, 8, and then it's got the map. So I'm not going to draw that array. You know what's sitting outside it. I'm just going to do this, and I'm going to say 0, 1, 2, 3, 4, blah, 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 blah. Okay, This that we're sending is 8. This that we have sent is 8 as well. And then we've got the map. Everything on the map is empty except for the player which has been placed. So it's going to have all those dots on every single one. And then somewhere here it's going to have just one player and then dots all around it. Okay, great. So I'm going to check now. Is row less than 0? Is 8 less than 0? No. Is 8 equal to 8? Yes, it is. So I'm going to return 0 from this function. So when I go up here, over here, it's going to say whilst, and this is going to be 0 inside there. Yeah? And what will that do? It will not do anything. It will not run. Okay? Yeah? Which means that because it's returned 0, and in here it's going to say 0, the 0 is going to go in there while 0. That means it's going to skip that whole loop, and it's going to go down to this here, and it's going to try and place the wall. And as soon as it tries to access this map row column, what's going to happen, it's going to go, oh no, absolutely not. I'm going to crash. I'm out of bounds. So I want this to not do that. And how would I do that? Pardon? Yes. What did I say? Oh, smiley face. I love negatives, which are actually really confusing when you're probably first starting to program. So I'm going to place a not here, for example. Okay, so let's see what happens if I place a not here. Hopefully that's really fun to see what's going on. Let me erase that. Okay, players now at 2, 3. I'm going to place one wall, and that wall is going to go at 8, 8. Okay, invalid spot, try again. -1, -1. Nope. 1 and 8. Nope. 4 and 5. Okay, so that's working. What about if I try and place it on the player? So 2, 3, and then I'll try and place it on the player. Nope, doesn't want to do that. Nope, doesn't want to do that. Okay, but if I do a valid input, it is okay. Okay. So now you're able to check for valid input and whether it's empty and not place things on top of other things. Okay, how is everyone feeling? Are you feeling good? Downtrodden? Just can't wait for Flex Week over this. Okay, great. We've got some walls. So now let's do some churros. Hey? You know, the thing is, churros is a really safe one because there are no good churros in Sydney. They are virtually impossible to find. What if you home make them? They're deceivingly not that easy to make. Yeah. You have to have a pot of oil and you have to really commit to it. I've tried many times. Yeah. Any questions? Come on, you're all dead on your feet. Liam, you dead? Okay. Let's do churros. Fine. Okay, let's place some. So we've placed some walls. We're now going to have a function. How exciting. And I'm going to call it place churros. And I'm going to give it the map again to place it on. Okay, great. So what do you think the place churros is going to look like? It's really going to look very similar to the one that we have over here, doesn't it? Does everyone feel that it's going to look very similar to our place walls? Yep. Oh, it's going to be exactly the same, except for a few things. So let's have a look. I'm going to be really... I'm going to copy and paste that, and we're going to change it. So this function is going to place some churros. We're still going to give it the map, and it's still going to output a void. So all of that remains the same. The only thing we're going to change is how many churros we're placing, And then here, where would you like to place a churro? And we're going to check the validity as well. And then we have to check one more thing, and we have to change this thing. What should that thing say? Yeah, oh, amazing. It's, yeah, instead of a wall, we're going to place a churro there. Okay, should we try it out? Let's try it out. Did I have a prototype? Oh, I didn't change the name of the function, did I? We haven't even moved to walking the player yet. That's next. We're going to walk next. Okay, great. Let's compile. And let's run it. And let's place it. By the end of this assignment, you'll get very sick of doing this. Oh, why did I do 2? Ugh. Okay, and then let's do 2 churros. Let's do one at 1.1 and one at 7.7. Okay, great. So I printed it out. I didn't even check if I'm placing it over something. Let's just assume that it works for now. Okay? I think it's time for us to do some moving. How do we feel? Otherwise, we've just placed things. Let's move things. Okay, so the next step is going to be, we've done that. So now we're moving here. Map is printed after every move. Player uses W, A, S, and D to move. So let's do our W, A, and S implementation. So let's do the actual implementation of what happens when we're moving. Okay, great. So after we've put all of our things on, I think what we're going to do here, so we've placed walls, we've placed churros, we've printed out the map, we've printed out some new lines, and now we want to actually play the game. So I'm going to call this function play game. And what are we going to give the function that's going to play the game for us? What should be the inputs be into it? I don't know why I'm looking at you to answer the question. Anyone? Anyone? I think a map is a good idea. What do you think? We want to give it the map. Someone's going to be moving on this board. Who's going to be moving on this board? Thank you, thank you, thank you, thank you. Okay, great. Okay, so let's have this function here that's now going to be playing the game. Okay, great. Now, is this function going to return anything to us? Will there be any output of this function? No, there won't be. It's a void function. Okay, and we've called the function play game. Amazing. And we're giving it a few things. We're giving it the map. So struct location map. My computer just died. I can't see anything that's happening over there now. It's this computer, it's not my computer. Someone's leaving. They've had enough of this. We haven't even moved the player. Okay. Great. So, you're moving the player with the letters W, S, A, or D. What does that mean we need to scan in? We need to scan in one of those characters, don't we? And what does that mean we need to do? Do we need to store that character? Yes, we do. Okay. So I'm going to have a variable for the move, and I'm going to hold that move in there. So I'm going to print. Will I print? Do I want to print the map? I've got the map. I don't need to print the map. Well, not yet. Okay. Okay, but I'm going to prompt for the move. Okay, great. What will I do next? Now, I will have to keep going with moving, don't I? And I have to keep taking in a W, A, S, or D until someone is over. Either they win the game, which we are not up to doing the win condition yet, or until the user presses Control D to stop. So, how will we implement that? Or So yes, but we check for the positive. Just so we know that one character has to come through, so we're going to check that it's equal to 1. But you are right, there's ways to also check for other things to see that it's, because there's other things that we want to trigger getting out of it, so not just -1. So I'm going to scan in this character, and I'm going to place it inside this move. And as long as I'm scanning this character, so as long as the output of this scanf function is equal to 1, and remember that scanf returns the number of things that it scanned successfully. So as long as that's equal to 1, I'm going to keep scanning, and I'm going to keep going, and I'm going to keep doing some things. Okay? So now I need to actually do the logic of the movement. So let's say I am over here, and I have scanned in a W, which means I move up 1. Yeah? So if I'm over here right now, which is, oh, why did I have to place myself? What was it? 3, 4, 2, 3, 2, 3, 0, 1, 2. So I'm at 2, 3, and if I change and move up, what's going to change? The row or the column? I hate rows and columns, by the way. They drive me insane. Half the time I will run it, and then I'll have to change it because I've changed the row, not the column. Okay, so we're going to check first whether it's up and then do something. Yeah? Okay, so I'm going to use an if statement, and I'm going to say if move is equal to, okay, I'm going to check whether or not it's equal to up. And remember that over here we have defined that up is equal to W. So this makes it easier to read. It's the same as me saying, okay, is it equal to W? Yeah? Okay, so if it is equal to W, then I'm going to change something. What will I change? Yeah, so I'm going to subtract 1 from the row. Okay, great. And what will I do next? I should check if it's valid. Let's just do all of them before checking valid. Then we'll go back and check valid. Because now we've got the problem we're moving, but we might walk into something, or we might walk onto a churro and then we have to collect it. Okay, so now I'm going to do my other ones. So else if move is equal to down. So what will change if I go down? So if I go down 1, then what will increase or decrease? Yep, row. And if I moved up, the row was minus. So if I move down, the row will become plus, I imagine. Now let's move to the left and right. Another weakness. So if I'm moving to the left, so I'm moving to this direction, then am I getting less or more? Less, yep. So I'm going to subtract from the column. And then finally, if my move is to the right, so if I move this way, then what happens to my column? Up, yep, so it gets bigger. Okay, great. Now, I've moved the player. I've moved them hypothetically, but now I need to change the board to reflect these moves. Yeah? So I need to place the player now wherever they needed to go, and then where the player was is now going to become an empty space. Yeah? Yeah? Yes. Amazing. Okay, before we checked anything is valid, so we don't care about that yet. One step at a time. Always do baby steps. Simple thing first, then move on. Okay, so how will I do that? Bye. Sad face. Hey? It is really sad. You have no idea. Lots of things are very sad on a Monday. Yeah, just throw some into the crowd. My God, everyone needs it. There you go, everyone's awake. I hope you're doing better on the assignment than this. What about behind you? It's all into the center. What about the people on the very right, my right? Oh my God, that was intense. That was angry. Was that Liam? Ah. You didn't get any on that side. You're going to have to walk. Not bad. Yeah. You're getting better, like towards the top. You need to go column plus plus and row plus plus. Oh, very good. See, it's like a death trap in here. Hey? Well, there's some chopper chops in there. You should go hand them out. Let people live. Okay, so I need to set some things. I need to do some things. I want to change the, what's going to happen now if I try and say, okay, actually now I want the map at row column, and now it's like dead again because I'm talking about this. Not long to go, I swear, like 10 minutes. Go on then. Yeah, okay. Okay, I do, yes, you're right. I don't actually have a row or column. How fun. That is really fun. Okay, great. Hey? And I do need to make them equal to something. Otherwise, what's going to happen when it gets to here, it's going to go, excuse me, that's a bit rude. They're not initialized. Oh, I don't want to make them equal to 0. What do I want to do with them? Hey?
Could you pass it in from when you initialize it?
That would be so good. So far, I'm passing in the map. But I can also pass in the player's location, which is a struct, which will kind of solve that for me as well, and it will be a much neater way to do it. So let's do that. When we play the game, I'm the issue, not, we did that there. So we're going to pass in that struct player. There we go. We've passed in the player. Okay, great. Hey? Does that mean we should also pass it out? What a good question. We shall see the answer to that. But again, it depends what we do. Not right now. But, okay, great. I've got something happening. What should I set the row and the column to? What do we think? Yep, excellent. I'm going to set it to where that player is sitting. So the player is over here. I've passed their coordinates. So they are at hero.x and hero.y. So right now the row and the column are at these coordinates, and I'm changing them over here. Okay, great. So now what do I do? I want to set this tile now, a new tile to where the player is now standing, or a pair. So what will that, is that correct to set it now to the player? We can always just try it. We can always try it. Should we try it? Should we see what it does?
It's going to leave a trail of players behind you as you go there.
It will, yep, because we haven't reset to empties yet. Very good. Did everyone else hear that? It's going to give us, here we go. This is what it's going to do because, hey? More than a semicolon. I've done something else too. I haven't done a prototype. Okay, let's do it. One wall. Walls at 3, 3. One churro. 4, 4. Okay, I'm going to, so the move is working. I'm going to move up 1. So I'm going to press W. Nothing has happened. I'm going to move down 1. Nothing has happened. Nothing. I'm not even printing the board again, which is why nothing is happening. But I'm going to press Control D. Let's print the board so we can see what's going on, because it's going to be, so over here we're going to need to print the board again. Where are we going to print the map? We want to print it after every move that we make. So let's print the map here. We're going to print the map, and we're also going to ask for the next move. So I'm going to do that in there as well, because that quite annoyed me. Okay, let's try this again quickly. Oh, I did not mean to do that. Okay, great. So I'm going to move up, and it has moved up 1, but it's also still standing on the side. And if I move to the side, it's still standing over here. So exactly what the person here said. We're leaving a trail of P's everywhere because we haven't actually reset the old position to be empty again. So we've moved the player, but we haven't reset where they used to be empty. So how will we do that? Where are we going to reset that? What will be the coordinate of that?
You do it before you move the column variables.
Do it before I move them? So which line would you like me to do it on?
Right after the while loop, after line 76.
Okay, so you are saying over here.
Then that means you don't need to track what direction it is and then remove it after moving.
It's true. So then what will I change here?
Make it empty.
The row and the column.
Yeah, row and column becomes empty.
So if it's empty, then, okay, yep. Okay, so let's give it a whirl. Yes. So dot tile is equal to empty. Yep. Okay, let's try it. This is going to start to drive you insane when you do the assignment. Okay, great. Let's move. I'm going to move up 1. That's working. I'm going to move to the side. I'm going to move to the side again. I'm going to move to the side again. I'm going to move down. I'm going to move down. I'm going to move to the left. I'm going to do to the left. I'm going to move to the left. I'm going to move to the left. Ah, swallowed up the C, but nothing happened. Can I move into a wall? Yes, I can. I can do magical things and overwrite them. That's because we haven't taken care of it yet. Okay, how does this first bit feel? Is that all right? Yep, okay, great. Okay, so what do we want to do now? So we've kind of checked all of that. Do we want to now check whether it's a valid move that the player is making? Yep, we so do. There's like 3 minutes left. I swear you can do it. Come on, let's just check the valid move, okay? What? Yes, let's check a valid move. Okay, where are we going to check the valid move? Are we going to check it beforehand? Are we going to check it afterwards? Are we going to check it before we assign it to our coordinate? Are we going to check it afterwards? Yeah, okay, let's do it. Excellent. So what are we going to check? We're going to check that it's not outside of the boundary of the wall, because right now I could move that player out onto the side. I can keep going. So we can call the function, except that what's the function checking? It's checking for outside of boundaries, and it's checking that it's empty, not empty. Yeah, still okay. Let's call the function, but we want it to hit a wall. If it's hit a wall, no, it's still going to work for us. Let's try calling the function. Okay. How are we going to call the function? Oh my God, everyone's dying, including me. Yeah, come on. Check validity. Such a great name. Okay. I'm going to check the validity of, I've forgotten what I've sent to that function, int, row, column, and map. Okay, that makes sense. Okay, so we're going to give it the row, the column, and the map. And remember, this will return 0 if it cannot go there. So I'm going to make it, so if it's all good, then I'm going to do something. Am I going to move the player here, or I'm going to say it's not valid? Okay, let's try. Okay, if I do have a not valid thing here, yeah, what will we do next? Nothing, yeah? Because it will catch it on the next move. It will allow it to make a next move over here. Okay, so let's just try it and see what it does. It's not going to work right now because I'm still writing it here. I always get pressured when it's 12:55 to finish too quickly. Okay, how's everyone feeling? Would you rather I just explain it properly tomorrow? Yeah? Yeah, you dead? You cooked? Yeah? Okay, you cooked. I'm cooked. Okay. All right. Good job, everyone. You can do this.